on the second half of the lesson. So let's dilate the triangle by a scale factor of 3 using C as the center of dilation. So I'm going to do this one. The rest of them I'm going to have you do on your own after I show you the images. But let's do this one together. So from C, we're dilating by a scale factor of 3. So dilation, choose the point, that's C, and it's a scale factor of 3. Okay. All right. I want to apply it to this one. Apply. This one. And then this one. Apply. All right. And then just to finish it up here, I want to make sure that this looks good. So I'm going to just make this a polygon. And you don't have to do this part. I'm actually just adding this part in just to really articulate what's going on here. Okay, so this is the image you end up with, and it should look something like this one right here. Now, what are the lengths of the segments in your dilation? Well, we know it was dilated by a scale factor of 3. So for number 1, C to H prime, if it was a distance of 2 here, that means this is going to be 6. Because 2 times 2 times 2. No, not 2 times 2 times 2. Sorry, 2 times 3 is 6. Now 1.5 times 3 is going to be 4.5. And then finally, the last one, the 1.7 times 3 is going to be 5.1. All right, nice job on your dilations here. Okay, let's move to this next one. So this is the same idea. Dilate the triangle by a scale factor of 3 using C as the center of dilation, except that C is out here. So when you define your transformation, you're going to choose C as your center, and then apply 3, and then select your points. So here, and then the rest of them, and then go ahead and connect them. And then you should get an image that looks like this. And then give me the lengths of the segments in your dilation. Notice I didn't give you any distances here. So in order to get those distances, you're going to have to do some measuring. And in order to measure, I'm going to draw a segment from here. I'm just going to do it all the way there to give me that measurement. And I'll select it and then add the label of length, and it's about 6, which tells me that this right here, which tells me that the segment from here to here is going to be something else. It's going to be 2. So this is 2. Now scale factor of 3, so this is going to be 6. Now you know how to get these distances. Now you can answer these questions. So number 1, we know was 6. So see if you can give me 2 and number 3 measuring these distances the same way we did it here. All right, let's go to this last one. Scale the triangle by 0.5. So same idea. Let's go ahead and transform, define, select dilation, choose C as your center, and then you want to do this by 0.5. And I want to dilate F. And then I want to dilate G. And then I want to dilate H. And then you'll draw the image. And you'll get, when you're finished, you'll get a shape that looks like this. Just like there it is. Now, what are the lengths of the segments of dilation? Same idea as before. You're going to have to measure, again, and figure out those images. So here to here, add label, and that is 1, which means that tells me this was 2. Because 2 times 0.5 is 1. And then you'll get the distance from here to here, and then here to here. All right, so this brings us to our definition. Now, scale factor is the factor by which every length in an original figure is multiplied when you make a scaled copy. Now, this definition is going to change just a little bit as we get further and further into the unit. But for right now, you can kind of get the idea of like applying a scale factor to this distance. Like this distance from C to F is 2. And I applied a scale factor of 0.5 to it, so 2 times 0.5 is 1. So you can see how this works. Now for this last part, let's go ahead and try this one. This is the same idea. You've got a triangle PQR, not shown here, PQR prime, is a dilation of triangle PQR using C as the center and a scale factor of 1.5. Is triangle PQR prime larger or smaller than triangle PQR? And explain how you know. I know that triangle PQR prime is going to be larger than triangle PQR because the scale factor is 1.5. One good rule of thumb is that scale factor is represented by K. Just a quick note, it's represented by K because a German mathematician found scale factor. K is represented with the word constant spelled with a K, but it's the German constant, so it starts with the letter K. That's why we are stuck with this as scale factor. So if K is less than 1, then it's going to get smaller. But if K is greater than 1, it's going to get larger. This is a good rule to follow. This is always how it's going to work. If K is smaller than 1, if K is less than 1, it's going to get smaller. If K is greater than 1, it's going to get larger. Notice that 1.5 is larger than 1, therefore K is going to get larger. So if I want to know what the length of P to Q is going to be, I'm just going to multiply by 1.5. So 5 times 1.5 is going to give me 7.5. Is that correct? 5 times is going to give me 7.5. So number 2 is going to be 7.5. Okay. All right. For the last part of this lesson, just what is one thing you learned today? And tell me something you like you know about you. All right.